what we talked about last class. We looked at classifying triangles, and we talked specifically about interior angles in a triangle. What did we learn about the interior angles in a triangle? Thank you. They sum to 180 degrees. What we're going to talk about today is exterior angles. And then specifically, we're going to do a deeper dive into isosceles and equilateral triangles. Well, let's talk about exterior angles first. An exterior angle is the angle that is formed by one side of a triangle and then extending that side. Okay, so it's extending only one side. So what I want you to notice in the figure, if I extended this side also, this angle right here is not an exterior angle, not in between the two. You extend one side and look at that angle that's created. So if we extended this one, that doesn't do anything for us. So it's one side only. Here is the big idea. It's not 180. The exterior angle is equal to the sum of the non-adjacent interior angles. So what I mean by that is this angle right here, the exterior, is the sum of the two interior that are not next to it. So what you notice is we do not care about the angle that's right next to it. These still add to 180. That's still true. But D is equal to the sum of those two. Okay. So here is an example. We notice this line was extended, so we have an exterior angle. So that exterior angle then is equal to the sum of the two interior that are not next to it. So we don't care about that angle. Oh, that's confusing. We do not care about that angle because it's right next to it. We care about these two instead. So we would get x add 73. And then we just solve from there like normal. So I can subtract x. So I get 2x subtract 9 equals 73. If I add 9, I get 2x equals 82. And dividing by 2 then gives us x is equal to 41. And that's the whole idea. On the next page, I would like you to do these two at the top, please. Good luck. This is what I got. So exterior angle is the sum of the two interior that it's not next to, 139 degrees. Same idea here. That first problem, how else could you have approached this? What's a different way that you could have done this? In fact, that we did this 10 minutes ago when somebody asked a question on the homework. Okay, I'm going to put somebody on the spot then. Caleb, can you tell me how you approached this? Because I noticed you did it a little differently.
I just added 75.
You had an angle here. How would I find that angle?
Oh, that would subtract 180 by 75 and 64.
Okay, if we take 180, thank you, and we subtract 75 and we subtract 64, I think we get 41 degrees. Zulkarnain, how is that helpful? Can I find the exterior angle using the 41? Charlie, what do you think? For the first one, if I have that 41 degrees, is there a way I can find this angle?
Yes.
How?
You subtract it from 180.
Exactly. If I take 180 and I subtract 41, in the back, stop, please. It will give us that angle on the outside. That is another way to get the 139 degrees. Manny, is that what you were going to say?
Yeah.
Great. Did that go okay? Okay, moving on. Talking about isosceles triangles. What does it mean, an isosceles triangle? Like, what makes a triangle isosceles? Thank you. Two congruent sides. So write that down. Two congruent sides. Okay, here's what I need you to know. I'm going to point out some of these vocab words. The legs are the sides that are congruent. So we notice on this figure, the legs are these two congruent sides. The side that is different, so the one that is not congruent, is called the base. The other word is base angles. Base angles are the two angles on the base. Here's what is important about isosceles triangles. If two of the sides are congruent, two angles also have to be congruent. That is the deal with isosceles triangles. That's what this second figure shows. And it's not just any two angles. It is the angles across from the sides. So if you have an isosceles triangle, two sides are the same, two angles also have to be the same. And it is the angles across from those sides. That's basically what that says. So let's do some examples. So here we go. What we're thinking when we look at this is we say, oh, we have two sides that are congruent. That makes this an isosceles triangle. If the two sides are the same, the angles across from those sides also have to be the same, which means this angle right here has to be congruent to this angle right here, which means this missing angle is 65. Now that I know that, how can I find y? Thank you, Avery. Add it all up, set it equal to 180. So we get 3y add 132 is equal to 180. If I subtract 132, I don't know what I get. 48 maybe? Does that seem right? Thank you. If I divide by 3, my y is 16. Okay on that? Okay. So, last thing to talk about, equilateral triangles. And I already told you this last class. Every equilateral triangle is also equiangular. So what I'm saying is, if all of the sides are congruent, then the angles are too. And it also works the other way. If the triangle is equiangular, if all the angles are congruent, we know all of the sides will be congruent. So then this is a great question. If we have an equilateral triangle, which means it's also equiangular, all the angles are the same, what does each angle have to be then? 60. Yeah, that's the only way that they could all be the same and add up to 180. This was very bare bones notes. Do you have questions for me?